First of all, always factor your numerator and denominator and check for common factors. If there's a common factor, cancel it and remember that there will be a hole in your graph. And then find your x and y intercepts and your asymptotes. And now here's a shortcut. You look at the multiplicity of your factors. For factors in the numerator, an even multiplicity implies that your graph will touch the x-axis at the corresponding x-intercept, and an odd multiplicity means that the graph will cross it. For your factors in the numerator, those are the ones that determine your vertical asymptotes. If it's an even multiplicity, the graph will go the same direction on both sides of the vertical asymptote. So the graph will shoot down on both sides or shoot up on both sides of the asymptote. If it's odd, the graph will switch directions. Then you use a starting point and use logic to draw the graph. You could say, if I go this way or if I go that way, what will happen? And usually you can eliminate one of the directions. Then plot additional points as necessary. Let's graph this function. Notice it's in reduced form, so we won't have any holes. Let's find our intercepts. The x-intercept we find by setting our numerator to 0, so it's going to be -2, 0. Y-intercept you find by setting x to 0, so we have 0, -2. Vertical asymptotes, we find out where the denominator is 0, and we're going to get x equals 2 and x equals -1. For horizontal asymptotes, let's take the ratio of the leading terms. If you FOIL this out, our leading term is going to be an x cubed in the numerator. The denominator, we're going to have a 2. We're going to have an x from this one and an x squared from that one. So we'll have an x cubed. So this equals 1/2. Y equals 1/2 is our horizontal asymptote. Let's start with graphing that information. I'm going to make a rough draft of the graph to start with. Now we pick a starting point and use logic from there to see what's happening. Now let's start at the x-intercept -2. We can either go this direction or this direction. Well, I know I'm going to end up along the horizontal asymptote. If I went down, I'd have to come back up and cross the x-axis somewhere, but there's no more x-intercepts, so I gotta be like this. Now I need to know if I cross or touch at x equals -2. Well, it came from the factor x plus 2, and that's cubed. It has an odd multiplicity, which means I cross. Now I need to know if I go down or up along this vertical asymptote. Well, if I shoot up, I'm going to have to cross the x-axis to get there. There's no more x-intercepts there, so I know I have to shoot down. Now I need to know what happens as I cross over x equals -1. Well, it came from this factor x plus 1. Its multiplicity is 2. Since it's even, it doesn't change sign, so we're going to be shooting down on the other side. Next I'll go to the y-intercept, and I have another vertical asymptote coming. Need to know if I go down or up. If I go up, I'm going to have to cross the x-axis, but there's no x-intercept, so I know I got to go down. Okay, let's cross our vertical asymptote. That came from the factor x minus 2. Its multiplicity is odd, so I'm going to change sign when I cross. So I'm going to be shooting up. Now there's no x-intercepts for me to come down to, so I'm just going to go like this along horizontal asymptote. So there's a rough draft of the graph. Now let's plot some additional points to make it more accurate. 3 would be a good one. So would 1. And maybe -1.5. And a -3. Just to get an idea of how steep we were going down. So now let's add these ordered pairs to the graph. We have 3 and approximately 4. 1, negative 3.5-ish. Negative 1.5 is negative 1/14. We're just barely below the x-axis. And at negative 3, we're 1/40th, so we're just barely above. Let's make our final draft now. So on the left, we are so close to the x-axis. This is progressing very, very, very slowly towards this horizontal asymptote. And over here, it's very flat still. And then we're going to shoot down. Then we have between the asymptotes, something like this. The exact maximum we would need calculus to find out. And then to the right, there it is.